So we've been introduced to the primary trig ratios, sine, cosine, and tangent. Now today we're going to take a look at how we can use those trig ratios to find side lengths in triangles. So our goal is to use the three primary trig ratios to solve for sides in right triangles. So we can use these ratios to find the missing side as long as we know one side and one angle in the triangle. And when we say one angle here, we mean an angle that is not the 90-degree angle. Because all these triangles have 90-degree angles in them. So for instance, in example 1a here, we want to find the length of side x. We know one angle, and we know one side. We're going to use that to find one of the other sides. So in this case, we're using angle 35. Side x is opposite to 35. And the side with 12 on it is adjacent to the 35. It's beside it. So they've already told us that we're going to be using the tangent ratio, and that makes sense. We've got opposite and adjacent here. So let's not forget our TOA. So in this case, we've got tan theta equals opposite over adjacent, and now we'll sub in what we know. So we know the angle, so we know what theta is. That's tan 35. So remember in these formulas, when you're trying to substitute things in, it's always the angle that gets substituted in for theta into these formulas. So you don't want to mix up the sides and the angles. So we have tan 35. Opposite is where the x is in the triangle, and adjacent is 12. So to calculate, to get x by itself, I'm going to move this 12 to the other side, and it's going to change from divide to multiply. So when it goes to the other side, it's going to be 12 times tan 35. And that equals x. So on the calculator, to do that calculation, and again, it depends on your calculator. It's important that you know your calculator. Make sure your calculator is in degrees, first of all. And then for my calculator, I'm going to punch in 12 times tan and 35 degrees. And then I'm going to hit enter. And we're rounding to 2 decimal places. So in this case, my answer for x is going to be 8.40. And we're working in meters, so that'll be meters there. Now, if your calculator, you have to punch things in a different order, you're going to have to punch in 12 times 35 tan, and then make sure you hit equals at the end, and that will give you the 8.40, or the answer that I have on my calculator there. So you really need to bring the same scientific calculator to class every day so that you get used to using all those buttons. There's a lot more buttons than we'll be using in this grade 10 course compared to the grade 9 course, so you want to be comfortable with that. In B, we're working with this angle 50. Side 15 is opposite, and side x is adjacent. So again, we're working with tan. This time the angle is 50 degrees. The opposite side is 15, and the adjacent side is x. Now, if you compare this equation to the one that we just did up above here, it looks a little bit different because in the equation up above, the x was in the numerator, the x was on top. Here, the x is in the denominator, it's on the bottom. And so, in order to isolate x in this equation, we need the x to be up on the top, not on the bottom. So to get the x on the top, we're actually going to move the x to the other side of the equal sign, and it would multiply by the tan 50. So it's kind of like the x would go out in front here multiplying by tan 50. But then to get x by itself, we would turn around and move the tan 50 to the other side and divide it. So what actually happens in this step is we just swap the x and the tan 50 for each other. So the x moves to the left side, it moves up on top to multiply, and the tan 50 would go to the right side and change to divide. So when we punch in 15 divided by tan 50, on my calculator I would punch in 15 divided by tan 50, oops, try again, 50, and then enter. I'm going to get 12.59 if I round to 2 decimal places. And this one doesn't have any units, so we can just write it as 12.59. Okay? All right, so in example 2 here, similar question, we know one angle, we know one side, and we're trying to find a second side in this triangle. So it does tell me up above that I'm using the sine ratio, but imagine that I didn't know that. I would want to label my two sides that I'm working with in relation to my angle. So 2.2 is opposite the 15 degrees, and x is on the longest side, so that's the hypotenuse. So we are definitely using the sine ratio because it's opposite over hypotenuse. So sine theta, opposite over hypotenuse, and then we'll plug things in. So sine 15 equals opposite is 2.2, and hypotenuse is x. So you see we get the same situation here. So I'm going to swap my sine 15 with my x. So we need that x to be up on top. So it's going to be 2.2 divided by sine 15 degrees. And when I round that to 1 decimal place, it's going to be 8.5 meters. And it's always good to check, I said this before, but it's important to emphasize that when we get our answer, it should make sense in the diagram. So 8.5 makes sense as the length of x because you can see that this side is much longer than that side. So 8.5 compared to 2.2, that makes sense with the numbers that we have in the diagram. The third one here involves cosine. Same thing, we're working with 60. This is my hypotenuse. This is my adjacent. So cos theta adjacent over hypotenuse. So cos at 60 degrees equals, and this time x is on top, it's the adjacent, and 3.5 here. So the 3.5 this time is going to multiply by the cos 60 to get our answer there. And when you do that calculation, you get 1.8 centimeters when you round to 1 decimal place, and that definitely makes sense when you look at your diagram. Okay, so far so good. Let's take a look at example 4 here. In 4, we don't get as much direction as far as what we should use. It says find the length of the missing sides using sine, cosine, or tangent. Round answers to 1 decimal place. So to start with, you see that we've got a y here, and we've got an x here that we want to find. Okay? We've got the angle 33 that we're working with, and we've got 12.8. So we have an angle and a side, so we can definitely use that to find another side. Let's label our sides here. So, for instance, if I'm going to set up a plan here for my answer, let's say that my first step is to find x. So if I'm going to find x, I'm going to use the 33 and 12.8 along with the x to figure out what x is equal to. So I need to label side x in relation to the 33, so it's opposite. And the 12.8 that I'm going to use, it's hypotenuse. So I can kind of ignore the y for now, and I'll figure out what x is. So if it's opposite and hypotenuse, it's going to be sine theta is opposite over hypotenuse. It's going to be sine 33 degrees equals x is on the opposite side, and 12.8 is the hypotenuse. And just like the ones we did previously there, for this one, we'll move 12.8 over and multiply it by the 33. And when we multiply those together and round to one decimal place, we get side x is equal to 7 centimeters. Okay? Now, on the other side here, I've got y. So now I'm going to ignore the x and solve for y. So y is adjacent to the 33. So if I come over here, I'm going to find y. So I've labeled those. I've got h and a, so that's going to be cosine. So cos of theta is a over h. It's going to be cos 33 equals, and it's going to be y for the adjacent side, and 12.8 for the hypotenuse. I'm running out of room here. Let's see, I'll put that guy up there. I'll get a little bit of room here. So this last step, when I take the 12.8 to the other side, it's going to be 12.8 times cos 33 degrees. And when I do that, I should get for y about 10.7 centimeters when I round it to one decimal place. Okay? So at the bottom of this page there is a warm-up question. We'll actually do that at the beginning of class tomorrow just for practice, and then we will we'll work on these questions in the textbook. Okay? Great, we'll see you tomorrow.